Double angle and half angle identities explained by Justin D'Souza. The learning objectives of this lesson are to find values of sine and cosine using double angle identities and to find values of sine and cosine using half angle identities. For the double angle identities, there are certain set of formulas that are over here. We need to remember these. These are already proven formulas. It's easy to remember once you understand the pattern. Say for example, sine 2 theta. This is very important one. Here it becomes 2 sine theta cos theta. You can realize over here it was 2 theta, the theta value, whereas now it became theta and theta only. So this is a very crucial formula to solve this double angle easily. Now you can see this cos 2 theta. Here, this can be simplified as cos square theta minus sine square theta. Using Pythagorean identities, you can solve them again further and get them solved to 2 cos square minus 1 or 1 minus 2 sine square theta. And for tan theta, it is 2 tan theta divided by 1 minus tan square theta. So these are the formulas which you must remember, and once you remember these, we can easily solve problems. The first problem is to find the exact value of sine 2 theta. And the sine theta value is given. We need to find its double angle identity, and the quadrant is also given. Now, one important thing about the quadrant. Let me do the quadrant first. This is cast diagram, CAST. It's from 0 to 90, 90 to 180, 180 to 270, and lastly we come back to 360 itself. Now in this, the first quadrant, this is the one, second quadrant is over here, third quadrant and the fourth quadrant. First quadrant, all the trigonometry values are positive. So over here we don't need to bother, we have to just take positive values, that's it. But now in case if it was 90 to 180, when you're substituting in the sine 2 theta value, I'll just write the sine 2 theta value formula, the identity. It is 2 sine theta into cos theta. Now when you're substituting over here, the sine 2 theta, don't see over here, okay, if it's in second quadrant, this must be positive. No, it's not like that. You need to look into the sine and cos. This is only for sine thetas, cos thetas, not double angle identities, only theta values. Now here, if it was 90 to 180, whatever the sine value you consider would be positive, whereas cos would be negative. So your answer would have been negative ultimately. But now in this case, we have to consider 0 to 90. So both these sine and cos, whatever value you get must be only positive. Okay, this is important. Now, how do you find, you know sine theta is given, but how do you find cos theta? Now that is from the Pythagorean identity. We know sine square theta plus cos square theta equals 1, right? Now here substitute. Instead of sine, we have got 2/3 square plus what is cos square? Unknown. So leave it as it is, equals 1. Now I need to solve for cos square theta, that is equal to 1 minus, square this up, it will be 4 by 9. Now cos square theta equals, there is one whole minus 4 ninths of it. So if you take 4 out of 9s, you are remaining with 5 ninths. So you can just do 9 minus 4, that's 5 ninths. And then now you can take square root on both the sides, and it will be cos theta on the left side, and it will be plus or minus 5 root of 5 by 9. Now it is plus or minus root 5 by square root of 9 would be plus or minus 3. Plus or minus is already written over here. This is the cos theta value. It can be either plus or minus, but here we know it is from 0 to 90, so it must be positive only. Cos theta is plus root 5 by 3. This is the answer. Now once you find this cos theta, you can substitute back. Now I have done everything in detail, but honestly from here you can just put in the calculator, you will get this. But you'll not get in terms of fraction, you will get it as decimal. And you can put it over here and get the answer. That's also possible. Now from here you can directly get the answer, but I've just done these steps. Now let me do it over here as well. Sine 2 theta, substitute. 2 times, what is sine theta? It's 2/3. What is cos theta? It is root 5 by 3. Now let's solve. 2 times 2 is 4. Root 5 divided by 3 times 3 is 9. Yes, that's the answer. That's it. Over here we are getting positive. Now if it was any other quadrant, there'd be 1 plus 1, not any other quadrant, sorry. It depends. If it was in second or fourth quadrant, we would have minus. First and third, it's plus for sine 2 theta. This is the answer. 4 root 5 divided by 9. We will just check the answer over here. You can see they have used Pythagoras theorem and found it. The positive value is considered here. And now you just substitute the values and you got 4 root 5 by 9. That is what we also got. That's it. Now we have a practice problem. Please do try solving by yourselves in the detailed method. Now the detailed method will remain the same all the time. So now I will teach you the shortcut method, which only works when there are MCQs, when you have 4 options. You need to take out your calculators for this. Here you need to see what is given. Cos theta is given, right? That is negative 1 by thirds. It's in the second quadrant. So in the second quadrant, only sine is positive. Not this, the sine theta, okay? Now here we have got cos theta as negative 1 thirds. So just use shift and cos. You'll get cos inverse of what? Minus 1 thirds. And close the bracket. And the value is 109.47 degrees. Now, if you convert to radian, you'll get in terms of radian, but that's fine. Now you have in degrees. What do? That is the theta value. Just substitute in this. Sine 2, you need the exact value for sine 2 theta. That is the answer. That is 109.7. It's already saved. So I just put answer. And this is the answer. 0.6285. Now here I'm getting a minus sign. But will the answer be negative? Yes, because it will have sine 2 theta. What is the formula? Let's look over here. Sine 2 theta will be 2 times sine theta and cos theta. Now in 90 to 180 degree, sine is positive. Yes, but this cos will be negative, right? Whatever sine value you get, positive multiplied by negative, ultimately the answer will be minus, and this is the answer. But now the thing is, you will get in decimals. So if you have 4 options, if answer is questions are objective, then all you need to do is solve this and check, solve all the 4 answers and check which matches with the answer you obtained. I got 6285. So all I need to do is solve this up. Negative 4 root 2 divided by 9 is 0.6285. So this is the answer. And this is minus, and then it's touching with the fraction symbol. But just remember this minus and this symbol. So that's how we solve it. And you can use the same method for cos or sine, any of it, you know. The formulas each time changes. Now it's cos 2 theta. In the previous one, it was sine 2 theta. So based on the formula, you can solve it easily. I will solve this one. Now look at the question. You have got sine 2 theta. Now, there are 3 formulas of cos 2 theta, right? One is cos square minus sine square theta and everything. Then another one, there is sine cos theta. The last one, it was 1 minus 2 sine square theta. Now, look at this formula. If I use this formula, isn't it so easy? Why? Because I have sine, it will be 1 minus 2 times sine is already known, 2 by thirds square. So it will be 1 minus square of this is 4 by 9. And now it's simple solving. 1 minus 8 by 9, 4 times 2. Now one whole is there and you're taking out 8 of 8 nines. So you're remaining only with 1 nines, positive 1 9. So this will be your answer. And since over here sign is positive, it will be positive itself. So that's the answer, 1 9. If you're using the calculator method, it will work anyway. Only for double angle identities, it will definitely work. Directly, you can do the same method. Please do try these by yourselves because they are same straightforward problems. All you need to know is the formula over here now. See, the thing is, you need, let me just show you the formula for tan 2 theta. Now, this formula requires tan theta only. You don't need sine or cos. Now, first over here, in this case, there's only sine given. The cos was found for the previously. The same problem for this value of sine, we had found cosine was root 5 by 3. So it's directly taken. But in reality, you need to find cos by using Pythagorean identity, and then from sine and cos you need to find the tan theta, and from tan theta you can find the double angle identity. It's pretty much pretty much straightforward, but there is plenty of steps. That's the thing. I'll just repeat how to solve for tan 2 theta. Generally, they will give you the sine theta and cos theta value, or if tan theta value is given, it's very easy. So if sine and cos is given, substitute in the formula of tan theta. Tan theta is sine by cos. So whatever is sine divided by cos, and it is from 0 to 90, so both are positive. Next, what you basically do over here is solve it up, simplify, you get the answer. This value is of tan theta, which will be found to find tan double angle identity. That is, tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta. Substitute tan value and solve it accordingly. You can just put it in the calculator and you will get the answer. Now this is the answer. Let's just see whether it's continued over here. But you don't need to do all the steps. It might take a long time. So just from here, just from the substitution, you can put this entire thing in the calculator and solve it directly and you will get the answer. Okay. So just to save time, this is the answer. Next, then we have again about cos 2 theta. Please do solve this by yourselves. Now, which formula would you use? Use the formula. Okay, now it's not there. I will solve this one. Use the formula which has only cos in it. That is, once again, it is 2 cos squared theta minus 1. Here you need to just substitute cos theta, it's negative 1/3. Why it's negative? Because it's in the quadrant of 90 to 180, and 90 to 180 only sign is positive. Cos will be minus 1. Now when you solve this up, it's square over here. The sign dissolves anyways. It'll be 2 times 1 by 9 minus 1. This is 2 by 9 minus 1. Now here you have 1 as a whole negative. So whatever the answer you get, it will be minus 2 nines minus a whole. That would be negative 7 nines. You can just flip it. You just think, imagine in your head, from a whole you're taking 2 nines. So you remain with 7 parts by 9. But since the bigger number 1 is negative, it's minus. So this is the answer. It's 7 by 9. That's a negative 7 by 9. So that's the answer. So this is how we can solve. Look at the formula, look at the given, and then use the formula, appropriate formula. For cos 2 theta, you have the liberty to choose whichever formula, that is either 2 cos square theta minus 1 or 1 minus 2 sine square theta. So it's easy. If you're given sine theta, use the other formula. If you're cos theta, do the other one. Now tan 2 theta, we just saw a problem, so please do solve it. Do solve it and do check the answers over here. Or you can even check with the calculator method. Let me just show you the calculator method again. All you need to do is see what is given. It's cos theta that's given. That's cos inverse of negative 1 by thirds. The answer is 109.47. Now what you need to do is put it in this. Tan 2 times the answer, that is 0.808. Now if I solve this up, 4 root 2 divided by 7 will be the same thing, 0.808. That's the answer. So this much is about double angle identities. Now we will go to half angle identities, and these are the formulas to remember. Now here you cannot use calculator because there is square root involved, and there is more possibilities, and the calculator will not give you the correct answer. There are tricks and stuff like you need to understand in certain cases it's divided by 2 and everything, but it's very, very tricky, and that methods don't work uniformly throughout all the problems. So I won't be teaching any calculator method here. You need to solve this by yourself by using the formula. So we will solve these. Now first remember the formulas. If it is sine theta by 2, the formula is same, 1 minus the square root plus or minus square root of 1 minus cos theta by 2. If it is cos, this 1 minus becomes plus here. But as for tan, see, it's sine by cos, right? Just take the numerator of sine and denominator of cos, because you're dividing sine by cos. So this is the formula. So it's always root of 1 minus, it's always 1 minus for sine, plus for cos, and divided by 2. Let's start solving these problems. Here, your cos. So let's first write the identity for half angle identity for cos. That is square root. Over here, there is no choice. Okay, you can use a different formula or anything. There's only one set of formulas. So it's 1 plus cos theta divided by 2 here. Plus or minus because it's square root. We need cos itself, so sine doesn't help us. So what do we do is we need to find from Pythagorean identity. Sine squared theta plus cos squared theta equals 1. And it's in the third quadrant. That means sine and cos both are negative. Only tan is positive here. So let's substitute the values. Here what happens is it's 4 by 5 negative sign, but since square is there, it doesn't matter. Okay, plus cos squared theta equals 1. Now cos squared theta equals 1 minus, what is the answer for this? See, this minus is gone. When you square it, negative, 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 negative becomes positive. So it's 4 squared is 16 by 25. So you're taking out 16 out of 25th from a whole. So you're remaining with, you can just do 25 minus 16. That is 9 by 25. That's the answer. Here, cos square theta. If you're getting confused over here, you can just use the calculator and get it because you're allowed to use calculators. But if you're thinking how I did it directly, see you have a whole. Whole can be written as any number by any number. It's just 1, right? So I can write 25 by 25 here. Minus 16 by 25. So now you can see it's 25 minus 16, that is 9. The denominators are same, so you write it as 25, only once. So that is the answer over there. And now here, take the square root. So cos theta is square root of, plus or minus square root of 9 by 25. Both are perfect squares, so we have plus or minus 3 by 5. Now here, since it's in third quadrant, cos theta must be negative 3/5. So that is the answer, negative 3 by 5. Now what? You just substitute back over here. So it is plus or minus root of 1 plus negative 3/5 divided by 2. You can just put this in the calculator. You'll get the answer. It's plus or minus square root. Here you will have to solve it up. 1 minus 3/5. Now again, you can easily solve the fractions up. 3/5 is taken out of a whole, so you're remaining only with 2/5 divided by 2. Now what happens in this case? It is basically, you can cancel 2 and 2. It's going to be plus or minus root of 2 by 5 multiplied by this. When you take it as it changes, this denominator, the numerator in the down becomes the denominator over here. So it'll be half, okay? Cancels. You have the answer over here is plus or minus square root 1 by 5. So this is the answer, root 1 by 5. Or you can write 1 divided by root 5. So that will be the answer. Here we have got what? 3/5. Not plus or minus, it's negative. We need to consider the negative one and then substitute over here. And you are getting the answer, root plus or minus root 1 by 5. Now I'll tell you how they solved it. See, this much is correct. We got it correctly. But what they have done is, they have simplified this further. Now instead of writing as root together, they have split out the root. So it will be 1. Root 1 is 1. Root 5. Plus or minus. Now they want to make this denominator not a root, as a whole number. So what you can do is multiply both by root 5, root 5. This is basically 1. So you're not doing anything wrong. When you multiply this, what happens is 1 times root 5 is root 5 in the numerator, divided by root 5 times root 5 is whole number 5. So this is what happens. So this is how they got it. If in case you don't see this option, if this comes for options, you don't see option, then just make sure you simplify this using this. Otherwise, there's one more method. Put this in calculator and press SD and you will find it. I'll just show you how to do it. So in your calculator, if you type this value, 1 divided by 5, you're going to get some value that is 0.447. Now, you will have 4 options like this, right? Solve all of them and you will get only one correct answer. That will be for root 5 by 5, 0.447. This is how you can check the answer. Now, Okay, this there is one more thing here to remember. In the given question, the quadrant was third quadrant, that is 180 degree to 270, right? So theta was in this quadrant. So what will be theta by 2? It'll be half of this, right? So it'll be in 90 to 135 quadrant. So this is the quadrant that will lie, this particular value. So 90 to 135 is in which quadrant? It is basically the second quadrant, and only sign is positive over here. So we have got cos, so we consider the negative sign here. Now you might be wondering, okay, why didn't we do this for double angle identity? So we had to multiply 2 times theta, right? No, because over there were no square roots. We were getting either plus or minus. Directly after solving, we got directly plus or minus. But in this case, ultimate answer is always plus or minus, right? So that's why we need to look into the question what quadrant it falls in. Now, based on that quadrant, divided by 2, because we are doing 4 half angle identities, and then look now which quadrant it is. It's in quadrant 2. See, it was initially in quadrant 3, but the answer, sorry, not original, the answer that we obtained will be in quadrant 2. So here it is only sign that is positive, so we write negative root 5 by 5. Now do try to solve this problem by yourselves. Try to see how you will try to go about it. Here you can see it's 67.5. It's very hard to know the angle of 67.5, and since we're using half angle identities, we need to use the formula of cos theta by 2. But here this is not in terms of theta by 2. So what you do is multiply this by 2 and divide by 2. In a sense, you can see here, instead of writing cos 67.5, we can just write it as 135 by 2, which is the same value. If you multiply this twice, it's going to be 135 and divide by 2. It is same. See, 67.5 degrees is 135 by 2. And now 135 degree in the 16 point unit circle, you can remember the value for this. So the understanding is you will know cos 135 degrees and solve it, or you can use your calculators and find the value, and you can use applying the formula. Now here you can apply the half angle identities. Why? Because we know it is whatever half angle theta by 2 is square root of 1 plus cos theta. Now this is theta by 2. Okay, I'll just write it out over here. Now here whatever we got, cos 135 by 2 is equal to what? Cos theta by 2. So what is exactly cos theta? That is just the top one, cos 135. So now here the understanding is, if you know this already, 135 by 2, so you can apply cos theta as 135 and then solve it up. And then when you solve it over here, you get the answer. Okay, that no, here is the answer. This is the answer, final answer. Root of 2 minus root 2 by 2. Now, if you solve it directly from here, you can put this in calculator directly and solve it, it's fine. The only problem is you will get in decimal. So here these are just steps to solve it up. See now 1 minus root 2 by 2. What they have done is they have just split this 1 into 2 by 2, and then 2 is common denominator and 2 minus root 2 is there. Divided by the whole 2, and that will say this half. Basically, you know, when you bring this divided by 2 up, it will be half, isn't it? So you multiply this 2 and 2, you'll get 4. The numerator remains the same. Now over here they have split the radical symbol, numerator and denominator. That's it. And ultimately here root 4 is 2, so that is the simplified answer. You can't simplify further. I mean, even if you write decimal, if you solve the problems properly, write it in values, you can get it. If you have 4 options and this is one of the option, you can just solve them in the calculator and check which is your correct answer as well. So that's how we do it. Please do try to solve these by yourselves. Remember, it's sine theta by 2. Now here the formula is sine theta by 2, that is given by square root of 1 minus cos theta divided by 2. This is it. This is the formula. It should be plus or minus. Apply it and solve it. Now it's in the second quadrant. So remember, when you see, I've just go to the end now. Okay, that's not there. Anyways, now I will just tell you one important thing. Whatever the answer you get will be plus or minus, right? How do you solve it? Theta is in what range? Second quadrant means it is from 90 to 180 degrees. Now, since we are finding half angle, just divide it by 2, it will be 45 to 90. Now, what is 45 to 90 degrees? It is over here 45 90. That is, all trigonometric functions are positive. It's the first quadrant, all are positive, so it doesn't matter what this answer is written as positive over here. Okay, the final answer really you will have plus or minus. When we solve, we have seen it just a while ago, so instead of writing plus or minus, it should be only plus here. That's why there's no symbol, it's plus. Now we will solve a real world problem. Here we have Chicago's Buckingham Fountain contains jets placed at specific angles that shoot water onto the air to create arcs. You can see over here. When the stream of water shoots into the air with velocity v at an angle of theta with the horizontal, the model predicts that the water will travel a horizontal distance of d is equal to v square by g sine 2 theta and reach a maximum height of a given h is equal to v square by 2g sine square theta. The ratio of h to d, h divided by d, helps determine the total height and the width of the fountain. Express h by d as a function of theta. Here, all you need to do is just the ratio of h and d. So that is the height and the distance. H divided by d. Let's write the formulas. Now it's v. I will write the entire numerators. V square into sine square theta together. Divided by 2g. Now this whole thing is divided by d. What is d? That is v squared. See, it's over here it is square. Here it is 2 theta divided by g. Now let's solve it. V squared sine squared theta divided by 2g. Now this denominator, entire thing, I'll bring it up over here. It will flip. In this sense, g goes up, v squared sine 2 theta goes down. G divided by v squared sine 2 theta. And now you can cancel this g with this g and v squared with v squared. So what's remaining is sine squared theta divided by 2 times sine 2 theta. Now look here, they have clearly told in function as a function of theta, not 2 theta. So we know the formula for sine 2 theta, right? Substitute it. Sine square theta, it's 2. Again we have 2 sine 2 theta, right? Substitute. We have 2 sine theta cos theta. So here the square will cancel with this sine. So what is remaining? You're remaining with sine theta divided by 4 cos theta. How this 4? It's 2 times 2 is 4. Okay. So this is the thing. What is sine by cos? It is tan. So it's 1/4 tan theta. So this must be the answer. Let's just check if we missed anything. Yeah, it's 1/4 tan theta. So this is how we solve it. Some steps might vary, but whichever you're finding easy, you can solve it. What I've just written is the correct one itself. You can, if you're comfortable with these methods, just follow this method. So that's the answer over here. Now we have done similar problems like this. Just multiply this by 2 and solve it up, or you can even write it as double angle. But since over here, okay, you can make it as double angle. Anyhow, it's possible. See, I'll just show you. You can either do sine 135 times 2 would be 270 divided by 2. Now you can apply this formula, or also you can just divide this by 2. It will be sine 2 times, it will be 67.52 theta. But you're not going to do this because it's going to be just more complicated. So avoid doing this, whereas this would be the most preferable. And same thing over here. With the first thing, what I would personally do is I would convert this into degrees and then I would solve it up. So convert into degrees, then solve it up. It'll be much easier. The answers are over here. Please do try and solve this by yourself, and you can even put them directly in the calculator. Check it over here, sine 135. It's in degrees, so that's the answer. Now, if you put this, don't put it as pi. You won't get the answer. See, if you just put it cos 7, let me write divided by 8, and over here, if I just put the shift and pi, look, this is not the correct answer. Even if I solve this, that's not correct. So what you need to do is, instead of pi, you can put it as 180, because pi in terms of degree is 180. That would be the correct answer. Okay. Now here we got minus 0.938. Why? Because it won't give us in fractions like this, complicated ones. Let me solve this one and show you now. It's minus root of 2 plus root 2 divided by 2. Let me just take this answer out. So that was the answer. Yes, it's correct. So this is how we can easily solve it out and verify this particular identity. It's something we have done in the last lesson. If you have not watched the previous video, I would highly encourage you to watch the previous one. You can see the video link in the description as well. Just click on that. You can go to the verifying identities and you can recall it. Now here, how would you solve this is, you can start with the left side and then come over here, but I have tried solving both the ways. This left side is much tricky. See, when it's double angle or it is high, huge powers, say power 5, 6 and all, avoid that. Try solving this and get to the left side. Now here, I can see it's cot and cot. In such cases, if I'm going to substitute this, then what happens is numerator and denominator over here, numerator, some things will cancel. Look, cot is basically cos theta by sine theta minus 1 divided by cot again is cos theta by sine theta plus 1. Now looking at the theta, now if I take the LCM, the sine theta cancels off. Why? Now let me just show you. What happens is, if I take the LCM, over here there's nothing. So you can basically do sine theta divided by sine theta. In the sense, this denominator multiplied up and down here. It will be cos theta by sine theta minus sine theta. 1 times sine theta is sine theta itself and sine theta. Divide the entire thing by cos theta by sine theta plus again multiply sine denominator, opposite side denominator. Over here it's 1, so you multiply 1 and 1, it's going to be the same, so you just don't do it. Now what's going to happen here? It's going to be the numerators are different, cos theta minus sine theta divided by the denominators are just sine theta. Divide the entire thing by cos theta plus sine theta, divide by sine theta here. Now then, you can see these two denominators, just cancel it off. In this, otherwise you can just solve it like this. Cos theta minus sine theta divided by sine theta multiplied. What happens? This goes up and this is written down. See, it will be sine theta divided by cos theta plus sine theta. Now here sine theta cancels off and you're having cos theta minus sine theta divided by cos theta minus sine plus sine theta. Okay, this is just a little bit done. Still there's a lot of work to be done. Now if you look carefully from this step, you can jump till over here. Why? Because you can see the LCM sine theta is there, right? You can see this is going to be the LCM, and over here also sine theta will be the LCM. But only thing is sine minus sine, cos minus sine theta will be the numerator. This denominator will be cos plus sine theta. This cancels, right? So you can predict the step and directly write it, or just cancel it off and directly come over here. You can do that as well if you're very confident in your algebra. Now then, over here we have this part. How do we solve such problems? We have solved them before as well. How? By multiplying the conjugate. Whenever you see problems like this, you multiply the conjugate. Over here you did not, because cot is there. If it was sine and cos, you would have to try conjugates. But here it's cot. If you do the conjugate, there's no point here. You won't get any easy simplification. It'll just be more complicated with secant and stuff, you know. So that's why we solved it up and we got cos and sine. Now conjugate means denominator is there, right? The sign must be opposite. That's the conjugate. Cos theta minus over here divided by, it's cos theta minus sine theta. Okay. I just realized one thing. Here, conjugate won't help you. Look at the given question. What do we have to find? We need to find cos 2 theta by 1 plus sine 2 theta, right? If I do with the conjugate that's minus, it's going to be minus here. Plus and minus becomes minus. So looking at this, I will change mine, this multiplicand to plus and plus. Why? I'm strategically using this. Why? Because now in the numerator, I'm going to get this. I'll show in a while. Because I know for sure in the denominator it should be plus. If I have minus, it's just going to be more complicated. So that's the reason I'm doing it plus. Here in the numerator, we have this identity a minus b, a plus b, that is equal to a square minus b square. Look at this. A is cos, minus b is sine. Here also cos a plus sine. So based on that identity, we can write over here cos square theta, cos and cos, minus sine square theta. Divided by, what about this? You can either do the FOIL method, that is, say over here, a plus b, a plus b. You can just multiply like this, the FOIL, and you will get the answer, same answer. Or a plus b and a plus b is a plus b the whole square, that is a squared plus 2ab plus b squared, this identity, a plus b the whole square identity. Now if you do the FOIL, it will be sine, cos and cos, it's cos squared theta. Now you will do cos and sine. Then again cos and sine, it will be plus 2 times 2 cos and sine, or sine and cos, it's the same thing. I'll write sine first. Why? Because plus 2 sine theta into cos theta. Oh, you can write anything. Plus finally it will be last two terms square, that is sine square theta. Here. Now, do you recall any of these identities? What are these identities? Now, the denominator over here, sine square and cos square, what does that become? It becomes 1 because Pythagorean identity cos square plus sine square is 1. No, sorry, I have to first do the numerator. What is cos square minus sine square? Cos square minus sine square is cos 2 theta. That is the formula. Cos 2 theta is cos square. You can see over here, that's done. Cos square minus sine square is cos 2 theta. What about this? Sine and cos is 1 plus what is remaining? We are remaining with sine theta, cos theta. Now we know this is basically cos 2 theta divided by 1 plus sine 2 theta. That's the identity. 2 sine theta identity is sine 2 theta. So this is how basically we solved it out. It's crazy, isn't it? I'm sure it's not so easy at the first, but if you practice and then it'll be a bit easier. From year to year we go, then over here, and then I'll just write this is 1, 2, 3, then this was 4, then this was 5, 6, 7, and the final one was 8. I hope this is clear. Please try to understand each of the substitution, and that's how we go. Because if you go on the other side, it's there are certain jumps which we need to do. Say for example, now it's just from this step how you're going back. Yes, you can definitely go back. You can substitute this as, say, this formula, cos square theta minus sine square theta, and this as 2 sine theta cos theta. But this 1 needs to be substituted as cos square plus sine square. Now these are few things, it's not so easy. And then now splitting it out, this identity, okay, this is a plus b. Now you have to write this as like this. And this one over here, writing it in terms of a plus b the whole square. And getting back, it might be more difficult if you're going backwards. Rather than if you're solving this, you just simplify. Try to simplify, you will reach with this. So that's the verifying identities question. So that's how we do it over here. It's a bit lengthy. We have one more. Let me do this as well, because the identity, verifying identity, is not that easy. Now what's the problem here? We have 4 cos squared theta. Now when I look at this, I realize I'm not going to take this and go back. It's going to be very hard. So what I'll be doing is I will start with the left side. I can work something with this, and then I will try to reach to the right side. Looking at this, I can just realize this is sine square 2 theta. So let me first solve this up. Let me leave this cos square as it is, cos square x minus. Now this sine square means You can write it as sine 2 theta the whole square. Okay, that must be equal to that. That's fine. We'll write it later. This is the thing. It is sine 2 theta. The square, sine square means it's the entire square. Okay. But if it was cos x square, it's only for this square. This is how it is. And now we will split the formula. Use the formula for sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So here we have 4 cos square x. Let me just write it as this, minus 2 sine theta cos theta the whole square. Now, can you see any plus or minus over here? No, it's just multiplication, isn't it? So when it's only multiplication, remember you can square each of them individually. So 2 becomes 4. 2 square is 4. Sine becomes sine theta whole square, or I'll just write sine square theta. If you're removing from here, then you have to put bracket and put square. Otherwise, you just put sine square theta. It's the same thing. Just write it over here. Sine square theta is equal to sine theta the whole square. Okay. So that's what happened over here. These both are equal. And then over here it will be cos square theta. Now I can see there is 4 cos square. Okay, it's not theta. It's everywhere. It's x. Okay. If I'm writing theta, just understand that's x. It's the same thing. I'll just change it out over here. X over here, cos square x. This is the thing. Now I can remove 4 cos square x from here. Again, I'm writing a theta because I'm so used to it. Cos square x. You can just remove this out. And over here also, this is the same thing, right? You remove both the cases. So it'll be 1 because you're dividing both the sides by now. 4 cos square x. It's 1 over here at the left side. And over here, you're just remaining with sine square x. Now, what is sine square x plus cos square x equals to? That is 1, Pythagorean identity. So take this to the other side. It will be cos square x equals 1 minus sine square x. Okay. Here then, what you do is 4 cos square x into cos square x. Then if you just multiply these powers, it will be cos 2 plus 2 powers. When you multiply, it will be added. It will be power 4x. And yes, that is what we wanted. 4 cos to the power 4x is the right hand side. They both are equal, so hence we have proved it. Now even over here, you need to apply a lot of identities which you know and then substitute and solve it up. So please make sure you're thorough with the previous video, previous lesson. So please go to the description, be thorough with it, and then this will be a little bit easier. You can understand what's going on here. And that's the answer. You can do whichever method. Ultimately, the answer, both the equal to must be same. Both the sides must be same. So that's the end of this lesson. I hope you have found this helpful. Please do subscribe to my channel. It would mean so much to me. And please do share these videos with your friends, with anyone who might find it helpful. I would greatly appreciate it. And please do stay tuned for the next video. Until then, happy learning and see you soon.